Welcome everyone. This is 6.3 on interpreting vertex and standard form. So last lesson, right, we went over and we talked about vertex form, and I introduced to you the parent function of a quadratic, right? Y equals x squared. And we talked about vertex form and where the vertex is and the special qualities about the vertex. Now we're getting into standard form of a quadratic, and the standard form of a quadratic is f of x equals a times x squared plus bx plus c, and also f of x equals y. If you did not know that, right, y equals f of x, okay? So your axis of symmetry is easily found by plugging it into this formula here. Negative b, x equals negative b over 2a. All right. Okay. And what I'm going to do now is I'm going to draw a little parabola here and show you guys a little special characteristic of the axis of symmetry and vertex. Okay, so there's 1, 1, there's negative 1, 1, and then I would draw two more points, but because the graph is so small, we could just work with this. Okay, and there's my parabola there, right? And remember that last class we talked about there's a special line that cuts it, a vertical line that cuts it, right? Called the axis of symmetry, right? So this line, the blue line, is you can find it by plugging in x equals negative b over 2a, okay, to find that specific point. And notice, class, that if you look at your vertex, right, negative b over 2a is actually the x coordinate of your vertex. That is because this vertex and the axis of symmetry will always be together. Okay, the x coordinate along with your vertex will always be along this line somewhere, right? We just don't know where, right? In our parent function, it's 0, 0, and your axis of symmetry is x equals 0, okay? So your x coordinate will always be equal to the axis of symmetry equation, okay? So again, wherever this moves, your vertex will also move with it. So that's why your vertex, the x coordinate of your vertex is negative b over 2a. Okay? So once you find your axis of symmetry, you also found the x coordinate of your vertex. So my question to you now is, what is this? What is my y value? F of negative b over 2a. What do I do to find f of negative b over 2a? How do I find it? To answer that question, let's talk about this, okay? Let's talk about this form of y equals, or f of x, I should say, f of x equals, I don't know, 2x minus 3. And I want to find f of 4. How would I find f of 4? So how do I get f of 4 then? When f of x equals 2x minus 3. What do I do with the 4? I plug it in for x, right? So 2 times 4 minus 3, that's 8 minus 3, that's 5, right? So I get my y value of 5 when x is 4. Same thing goes when I figure out what negative b over 2a is. Negative b over 2a is an actual number, right? And once I find out that number, I'm just going to plug in that number into my equation to figure out my y value. Does that make sense? Okay, so that's what we're going to do today in standard form. Sometimes we are going to get things in vertex form. So just as a refresher, right? Vertex form is f of x equals neg a times x minus h quantity squared plus k, where my axis of symmetry is x equals h, and my vertex is h comma k, right? And class, I want you to notice this too, okay? X equals h is my axis of symmetry, and the vertex, the x coordinate of my vertex is h. Okay, so it has that quality as the same thing as my standard form. Okay. Another thing to point out is that vertex form, in vertex form, this a is the same a in the standard form as well. Okay, so the a values are the same. Okay. So remember, when my a value is positive, it makes a happy face. Okay. So my vertex will serve as a minimum, the minimum point, the lowest point of my parabola. When my a is negative, it makes a frowny face, and that vertex point serves as the maximum, okay, or the highest point of this parabola. All right. Okay, so that kind of concludes the formal lesson, right? The note part of it. Well, the informational part of it, and then now we're going to get into some examples. All right. So my first example is this. Find the vertex of and axis of symmetry of this equation here, 4x squared minus 48x plus 147. So here, my a value is 4. My b value is negative 48. And notice that I took the sign with it. And my c value is positive 147, right? So I know my axis of symmetry is going to be x equals negative b over 2a, right? And if I plug in a and b into here, it'll be negative times negative 48 over 2 times 4, right? Simplifying this, negative times a negative is a positive, so it's positive 48 over 6 or 8, which will make it equal to 6, right? So my axis of symmetry is going to be x equals 6, okay? And again, because I got my axis of symmetry at x equals 6, I know that my vertex is going to be 6 comma blank, right? I'm not too sure what my y value is, but I know my x value is 6, right? So in order for me to figure out what my y value is, I'm going to plug in 6. I'm going to get f of 6. So if I get f of 6, that's 4 times 6 squared minus 48 times 6 plus 147. Okay. So that would be all sixes. Right? I'm going to plug in 6. So 4 times 6 squared. So 6 squared comes first. So that's 4 times 36. 4 times 36 is 144. Minus 48 times 6, that's 288. Plus 147. And if you do that math, right, f of 6 equals 3. Okay. So now my vertex point becomes 6, 3. Okay. So I found my vertex. I found my axis of symmetry. Okay. Questions on this? No? Pretty simple? Right? Okay. So my next example now, in general, determine whether the function represented by each equation is a quadratic. What makes a quadratic a quadratic? What special feature does it have? It has my variable has to be, the degree of the function has to be 2. So that means that the exponent, the highest exponent that I would see is a 2. Okay? So number 5, y equals negative 3x plus 15. This degree is 1 because this has a power of 1. Okay? So it's a no. That's not a quadratic. What is that? If I graph negative 3, y equals negative 3x plus 15, what type of thing would it be if I graphed it out? This will be a linear function. Okay? It'll be a line, right? With a slope of negative 3 and a y-intercept of 15. Number 6 here, we have x squared, right? Y has to have the power of 1. Okay, y minus 6 equals 2x squared. That is a quadratic. So yes. Okay, because the degree of that function is 2. Number 7, we have y, 3 plus y plus 5x squared. Here's the squared. There's no cube. So here, this is also a yes, because this degree is 2. Okay, number 8, y equals 6x plus or equals 14. Y plus 6x equals 14. This is a no. This is also a line or a linear function. Okay, because my x value here has an exponent of 1. All right. Quick and easy. We're good. So a quadratic is a quadratic when the degree is 2. Okay. Here, we have rewrite a quadratic function from vertex form to standard form. So we know it's a vertex form because this is outside being squared, right? X plus 5 quantity squared. Whenever you see quantity squared, that's in vertex form. So here we're going to expand this out. Okay. You guys remember how to expand that out without actually multiplying the special form? Remember the 2. special forms, a plus b quantity squared and a minus b quantity squared, a plus b and a minus b, the first term will be the first term squared. The last term will be the last term squared. Okay, the positive version of that. The middle term will always be 2 times your first term times the second term. Okay? The only difference between the plus and the minus, if this is a plus, this will be a plus. If this is a minus, this will be a minus. So replicating that with x plus 5 quantity squared, first term squared is x squared. Last term squared is 25. I'm going to give me a little bit more room. 2ab. So 2 times 5 is 10 times x is 10x, right? And that's a plus. And since this is a plus, this will also be a plus. So it breaks out to be that. X squared plus 10x plus 25, and then moving everything else down with it. Now here with this 2, I'm going to distribute that out. So that will give me 2x squared plus 20x plus 50 plus, and then everything else will just come down, equals y. And then I am going to gather the like terms, 2x squared plus 20x plus 53. That's in standard form. Okay. That's going to be my standard form. Cool. So number 10, how do I turn this using that? X minus 7 quantity squared. Remember, first term squared, last term squared. 2 times 7 is 49 or 14, right? Times x is 14x. Since that's a minus, this is also going to be a minus. Okay? Putting everything else down, times -3 equals y plus 2. I'm going to get the -3 now and distribute that out, right? So 3 times -3 times x squared is -3x squared. -3 times -14 is positive 42x. -3 times positive 49 is 147 plus 2, right? Plus 2 equals y. So here I just gather the like terms. That would be -3x squared plus 42x minus 145. Okay. Questions on that? Pretty simple. Yeah. My next 2 examples, you guys are going to be in the directions it says to put it in from vertex form to standard form. I'm going to skip it. Okay. We're going to do the same steps as these guys. Okay. So moving on to my next example. Now it says use the table. Instead of just giving it to us, they give us a table of values to write the quadratic function in vertex form. And remember, vertex form, right, is right here. y equals a times x minus h quantity squared plus k, and then rewrite it into standard form. So here you're given the vertex at 2, 5, right? So if I look at the table, this middle term here is actually my vertex, right? Remember, my vertex in vertex form is h comma k, right? Yeah. So I'm going to plug that in to my form there. Y equals a times x minus 2 quantity squared plus 5. Okay? I just plugged it in, right? And now, all of these guys, all the other points that I have, what do those represent? Those represent other points along my parabola. So for example, if I scroll down to my other one, this is a graph of a parabola, right? Here is my h comma k, right? And to make the parabola, we have all of these different x comma y values, right? All of these guys are x comma y, other points along the parabola, okay? In my table of values, we're given 4 of these points. So it doesn't matter which one I use. I can use any one of them, okay? And plug it in to x and y. We do that to figure out what my a value is, okay? So I'm going to pick one, and preferably I'm going to pick one that's easy, okay, the easiest numbers to deal with. I'm going to pick this one here, the 3, 11, okay? Or I can pick the 1, 11, but I'm going to stay away from the 59. So my y value now becomes 11. My x value now becomes 3. And if I do that, notice that I only have one variable to deal with, is the a, right? So I can solve for a by simplifying this. 11 equals a times 1 squared plus 5. 1 squared is 1, so that's just a plus 5 equals 11. So now I'm going to subtract 5 from both sides and get 6 equals a, right? Now I got 6 equals a as my a value. I'm going to plug this back into here. So my equation now would be y equals 6 times x minus 2 quantity squared plus 5. Now I have my points. And the reason why I don't have any values for x and y, and they're labeled x comma, they're labeled y equals and x minus 2, is because going back to my graph, I have a bunch, right? I have an infinite amount of x comma y's, right? This can be x comma y, this can be x comma y. All of these points can be x comma y, right? But there's only one vertex, right? Which is here, right? That's my vertex, yeah? There's only one a value of 6. So because there's only one a value and one vertex, now I can plug that into my equation and figure out what my other, that's why this is the equation of the vertex or of the parabola. Okay. Performing the same thing here. My vertex of the parabola is -2, -7. So I can say it's y equals a times x minus -2 squared plus -7. So this will be y equals a times x plus 2 quantity squared minus 7. Okay. And I can pick any other x and y. I'm going to pick that first one, 0, -27. So -27 equals 0 equals a times 0 plus 2 quantity squared minus 7. Right? I picked the point 0, -27. Okay. So if I simplify this, -27 equals a times 2 squared minus 7. 2 squared is 4. So that's 4a minus 7 equals -27. Add 7 to both sides. Then we get -20 equals 4a. Divide by 4, divide by 4, solving for a. That's -5. So now I can plug that back into my equation here, right? Plug this into there and get my equation that way. So that's y equals -5 times x plus 2 quantity squared minus 7. Okay. All right. Any questions on this? And then from here, you guys can figure out the standard form, right? By doing what we did previously. Okay. All right. So that's that. And my last example, we're going to go back to that graph. And instead of a table or instead of giving it to us, we have a graph, right? I know here, just by looking at this, A is going to be negative. My vertex is going to be 1, 1. And the point x, y that I'm going to choose is going to be 3, -3. Okay? So if I plug in everything, okay, into this equation here, okay, I'm going to plug in everything into there that I know. It's going to be f of x equals, I have no idea what my a value is. I have an x value of 3 minus h, which is 1, quantity squared, plus 1, right? So f of x is equal to a times 2 squared. Oh no, I know f of x too. I have that as -3 plus 1. So that's -3 equals 4a plus 1. So 4a is then equal to -4, and A is equal to -1, right? So my equation in vertex form would be y equals -1 times x minus 1 quantity squared plus 1. My vertex is 1, 1. So that's my equation there. And then from here, you guys can figure out the standard form by doing the same things that we did in our previous example. Okay? Cool? Yeah. Next lesson, we're gonna graph this. Okay, using standard form. All right. But that's the lesson for today, class.